If you look at the first step in the refinery, you take the crude oil, you heat it up at atmospheric pressure, and you separate out the naphtha, the kerosene, and the diesel, but you can't separate out the gas oil because the temperature required is so high that the big gas oil molecule will crack and the product will get ruined. So what you do is you take that material that includes the gas oil and asphalt, and you take it to another distillation column which is operated under low pressure, very low pressure, which is a vacuum, and under low pressure it's easier for it to boil at a lower temperature because it's fighting a lower pressure and can therefore escape out of the liquid phase. So that's how you separate the gas oil. Now that you've got all the various components, you need to process them and change the molecular shape to either make octane or to make cetane, and also remove certain impurities like sulfur. So let's take the naphtha. What you have is a light naphtha and a heavy naphtha. The light naphtha is maybe 100 to 200 degrees. In the old days you could put in lead and you would have a leaded gasoline and it would boost up the octane. Today you can't do it, so you have what's called an isomerization unit, and you take a straight chain paraffin and you make it into a branched isomer and you increase the octane by about 10 degrees, and that's what you do to get that octane back that you don't get with lead anymore. The heavy gasoline, which is from 200 to maybe 350, 400 degrees, what you do is you reform it, which means you take a paraffin and you make it into a naphthene, you bend it into a circular shape, and then you remove the hydrogen and you make it into an unsaturated circular shape, which is an aromatic, and you've got the highest octane and a byproduct of hydrogen. The value of this hydrogen is that you use it in what's called a hydrotreater to remove sulfur, which is a pollutant and a bad actor in all of your products, and that hydrogen reacts with the sulfur under high pressure in what's called a hydrotreater, and you can remove the sulfur from the product and make a clean product. So that's the benefit of the hydrogen that you make in the reformer, and you make a high octane. So that's how you convert low octane naphtha into high octane finished gasoline. In diesel fuel, you've got the kerosene, which is also a jet fuel. All you need to do is take out the sulfur and you've made a good product. In the heavy diesel, you take out the sulfur, and in California you have some specifications which require you to convert the aromatics into paraffins, because aromatics cause black smoke to come out of the engine, and that's a pollutant, and California has more rigid standards, so you have to saturate that aromatic and make it into a paraffin, so there's more processing required over there. But essentially it's removing the sulfur, and in California it's saturating the aromatics. Now the next step is that material from 650 to 1000, it's what we call gas oil, and there are two ways to process it. In the United States we have what's called a fluidized cat cracker, and what we do is we take a long molecule and we basically crack it with catalyst and make it into two small molecules. And as you know, if you have a long stick and it's easy to snap it into two, and that's exactly what you're doing, and you're using the catalyst just to enable it to snap it and make it into two smaller molecules, and essentially you make 80% gasoline and 20% diesel out of a cat cracker. That's because the demand for gasoline is much higher in the US. In Europe, the demand is for diesel fuel because of the high taxes that are there and the high price of fuel. They prefer to run diesel fuel because diesel engines give 30-35 miles per gallon compared to gasoline engines that give only 20 to 25 miles per gallon. So whereas in the US 95% of cars run on gasoline, in Europe over 60% run on diesel fuel. So there what they do is, instead of breaking up the molecule, they break up the molecule by adding hydrogen, and that way, instead of cracking it into smaller, very small molecules which fall in the gasoline boiling range, they break it up into bigger molecules that fall into the diesel boiling range, and that's how they make diesel fuel out of that fraction. And finally, you got the bottom of the barrel, which is asphalt, and since there's a limited amount of road work that you can do, and a limited use therefore for the asphalt, in most places like in California, they take that asphalt and they run it in a coker where they basically just boil it under very high temperature, and they break it up with temperature into small molecules, and they break it up into gasoline and diesel, and they reject the excess carbon and make a thing called petroleum coke, which gets exported as a fuel. Can't burn it really in the US because it's high in sulfur and wouldn't meet the environmental specifications. So that's how you do the separation of petroleum into its various components, and then how you change the shape of those molecules to get good octane for gasoline and good cetane for diesel, and how you remove the impurities like sulfur from the fuel.